All right, students, several problems from this worksheet, front and back. Notice the first one is on rectangles. It's defined as rectangle. Okay, so again, oops, I would look at my corollary hierarchy theorem and go down to rectangles. Remember, everything that's true of a rectangle, its definition plus its properties, also includes everything dealing with parallelograms, isosceles trapezoids, and trapezoids. So all these properties are true for a rectangle. So don't get caught only looking necessarily at the rectangle information. You may only need that, but you may have to use something from the parallelogram or isosceles trapezoid or trapezoid. Okay, it's probably going to be mostly from this. Okay, so UZ. UZ, we'll just do number one here. And ZS. UZ and ZS. What do you know about that? Since it is a parallelogram, not only do you know that they bisect each other, but also, going back on my isosceles triangle theorem here, I mean not isosceles, but rectangle, the diagonals are congruent. Notice diagonals, I use both. They're the same length. And from my parallelogram, what do the diagonals do? They bisect each other right there. So both those statements are true. The diagonals bisect each other and the diagonals are congruent. That's what I'm applying here. So that's why I can say all four of those pieces are the same. Okay, so set them equal to each other. UZ equals ZS. So go ahead and subtract x across, add the 15 across, and I get 2x equals 36, x equals 18. Go back and read the question. It didn't say solve for x. I'm not done. What does US mean? The length from U to S. So that means I can plug in either one. If I go to U to Z, then I have to double it, right? Because they're the same. US is all the way across. Okay, so if I look here, 18 plus 21 is 39. So this is 39. So then this is got to be 39. So 39 times 2 is 78 for my answer. Okay, so you're going ahead and using those characteristics to deal with rectangles. Down here, it's also a rectangle. So you're using it again with rectangles. Okay, remember, a rectangle is a parallelogram. So these are parallel lines cut by a transversal. What I tell you, the very first thing to think of, when I have parallel lines cut by a transversal, alternate interior angles are congruent. So if that's 37, then this down here is 37 automatically. Where you know the angles, the corners of all rectangles are 90 degrees. So if that's 37, then this one here has to be 53, right? And since this is also parallel to this, cut by this transversal, alternate interior angles are equal. Okay? So don't forget that information right there. I'll let you think about the others here. Okay, I'll just get you started right there. Remember the corners are 90 degrees. Okay. They bisect each other. That's your hint on that. That will help you with it. Hint is that the diagonals bisect each other. All right, here it's a rectangle as well. So this whole side is dealing with rectangles. More right here. Let's go ahead and do number 6. Measure angle BDC. BDC, right there. This angle can be compared with ADB. ADB, this angle right there. Okay. So we're comparing those two. Well, what do I know about those two angles? What do they add up to? Aren't all angles of a of a rectangle 90 degrees? So this angle plus this angle has to add to 90. So I have 16x minus 6 equals 90. Add the 6 across, I get 96. Divide by 16 and I get 6. So x is 6. Didn't ask for x, but it asked for the measure angle BDC. BDC. So this one right here. So I go ahead and fill in 6. 7 times 6 is 42 plus 1 is 43 degrees. So the measure of angle BDC equals 43 degrees. Okay. Just so you know, for the quiz on Friday, I will let you use your quadrilateral hierarchy theorem. Not for the test, though. But for the quiz, yes. So you need to get it memorized over the weekend for our test, because our test is next week, since this is the last part of Unit 1. Okay, we'll take a post-mod 1 edulastic test that we have to take. And this is we're at the end now. Now that edulastic test that you'll take in class, I'm not counting as a test, I'm going to count it as a quiz. Okay, just so you know that, but you will be taking it like the edulastic, so that's why we've been practicing edulastic, so you're familiar with everything on how the program works. All right, backside now. This is a rhombus right here. So you're dealing with rhombi. Rhombi is plural for rhombus. Rhombus is singular, rhombi plural. And squares. This one's a rhombus also. Okay. Down here, it's asking me to plot these points and figure out if it's a rhombus, rectangle, or square. And notice it says list all that apply. Okay. So use your quadrilateral hierarchy. Down here's a rhombus and a rhombus. So the main focus on this side is our rhombi. Okay, but here's where the rectangle or square come in plotting them. And you might have a question just like this on the DCAS where they give you 4 points, say plot them. They want to see if you can plot the points and then identify what parallelogram it is. Is it just a parallelogram? Is it a rhombus, rectangle, or square? Remember I told you those are the 4 that they focus on. So again, that means I'm going to use my rhombus definition and properties right here. And of course, that means everything that's underneath the parallelogram is also true. Those are going to be the main ones you're going to use. But if you need to, you could also use kite if you couldn't get the information from rhombus or parallelogram. Remember, kite falls underneath, is above rhombus. So all the characteristics of kite are also true of a rhombus. And of course, then we go up this way as well. So all the characteristics of a trapezoid are also true of a rhombus. Okay, just so you know that. So if it's not under rhombus and parallelogram, to get the information you need, then you go check kite and or trapezoid right there. Okay, so let's go ahead and look at our problem here. We'll go ahead and deal with this right here since we have a radical involved. Okay, if the length of PQ is 3 root 2 and AP is 3, find each measure. Okay, so rhombus, again, I look at the characteristics. Rhombus, oops, let me move this up so you can see the rhombus. The definition is 4 congruent sides. So first off, if that's 3 root 2, this is 3 root 2, this is 3 root 2, and this is 3 root 2. Okay, because 4 congruent sides. What else is true? The diagonals are perpendicular bisectors. That means both diagonals are perpendicular bisectors. So they bisect each other and they form 90 degrees in the middle. So let's make that 90 clear. So this is 90, this is 90, this is 90, and this is 90. Okay. They bisect each other. So that means this length is equal to this length, That 3 means this is also 3 right there. Okay. Now, to find this length for the middle AQ, I can use Pythagorean theorem because I don't have a right triangle there. So I can use Pythagorean theorem. We'll just call this x. So I'd have x squared plus 3 squared equals 3 root 2 squared. Isosceles Pythagorean theorem. So now I have x squared plus 9 equals, remember that means I have to distribute the 3 through both of these. That gives me 9 times 2. So now I have x squared equals 18 minus 9 is 9. And so x equals 3. Now technically it would be plus or minus 3, right? But you obviously can't have a negative length, so you blow off the negative answer. And so x is also 3. So AQ is 3. Now when we get to special right triangles, and you learn those well, then you'll learn how to get a shortcut to know that this answer was 3. But until then, you have to use Pythagorean theorem. Okay. Measure angle APQ. APQ, this angle, let's go. Okay, so if this now is 3, I have an isosceles right triangle. Okay, there's my middle, and there's my 3 and 3. And there's the 3 root 2 for the side. So I have an isosceles right triangle. That means both these angles have to be 45, right? Because they're complementary. So APQ has to be 45 degrees. Okay. So each of those is 45. 45 there, 45 there. Okay. And then don't forget we have alternate interior angles because they're parallelogram, right? A rhombus is a parallelogram, so that means this is 45. And the alternate angle here is 45. Okay. And so if that's 45 and that's 45, then I have an isosceles triangle. Okay. That's 3 right there. All right. So all these are 45s then right here. MNP, MNP, we know is therefore 90 degrees. So this rhombus also happens to be a square since their angles end up being 90 degrees. Okay. And then PM, the whole distance from P to M, 3 plus 3 is 6. All right, so there's an example there. Going through that. So again, I'm just showing you how you use your PQ. Wait a sec here. That's the exact same thing. PQ's AP is 3. Dang it. 1, 2, 3, 4, 5. What do we have up here? RK is 5, RY is 13. So these are the same thing. So obviously you can cross out this because we've already done them above. So on the back side, now you've only got 11 problems to do. It's the same. The first 8 are the same as these bottom 8 down here. I obviously accidentally copied them twice instead of from another sheet. Put it together. So on this back side, you've only got 1 through 11 to do. Okay. Front side, you have 1 through 11 and a 1 through 8 right there. All right, that'll do it.